All right, our next lesson here is lesson 1.4, where we're going to work with angles and their measures. We'll be doing some comparisons, kind of use of the protractor. It's a little hard when we're doing digital learning here to actually have a protractor, but at least we'll learn how to read one. And we'll go from there. So first of all, again, to repeat, you should be writing notes down. You can use them on the test since we're doing distance learning. And at the end of the chapter, I will be having you submit your notes to me so I can look through them. So here we have an angle over here. You'll note that its sides are made up of rays. Ray AB, remember we used that vertex to name the rays, so that's why the A is first, and ray AC meeting at the vertex makes an angle. Things to note about an angle. First of all, they're measured in, they're actually measured two ways, but in geometry, we'll be measuring them in degrees. In higher levels of math, we use a larger unit of measure. Now keep in mind what a unit of measure is. There's multiple ones. For example, your height, I could, it's usually done in feet and inches, like I'm 5'2". I could do that all in inches. I could do my height in centimeters. I could do my height in millimeters. But a degree is really, there's just 360 of them around a circle. So if you cut this into 360 slices, you'll know a degree is just going to be a tiny little unit of measure. And it's how many of those little units make up the interior of these two rays that is called the measure of the angle. So it's just a unit of measure, like inches, or centimeters or millimeters. Degrees are used to measure angles. All right, what else can we note about an angle? The rays that make it up are the sides, so we already said that, but we should put sides are rays that meet, or which meet, at what we call a vertex. So if I were to ask you, what's the vertex of this angle? You would say point A. All right. Now also, there's multiple ways to name an angle. So let's write that. Can be named multiple ways. This particular one up here can be named 4 ways. All right. Because of that number in here, I could call it angle 1, and you have to put that angle symbol in front of it, this little guy right here. Okay, indicates that we're talking about an angle, not a number 1. So I could call that angle 1, or I can name it with 3 letters. The vertex has to go in the middle. Where does it have to go? In the middle. So I could call it angle BAC. Or I could go the other way and call it angle CAB, but I have to have that vertex in the middle of the 3 letters. I also have to have that angle symbol in front, because remember, if I don't have that there, that's the notation for a plane. So I think, well, it doesn't matter. It does matter. Again, we talked about how this is different from this, is different from this. This is a number, it's how long a segment is, or the distance between 2 points A and B. This is a ray that shoots out from A, and this is a segment that connects A and B. So those little symbols mean a lot, so you have to make sure you put that angle symbol in front. Now also, because there's no other angle adjacent to this one, adjacent means next to. If for our angles, it means touching, but because there's only one angle here at vertex A, I could also call it angle A, honestly, and you know exactly what angle I'm talking about. Now, had I done another angle shooting this way, in which case I'd have what's called adjacent angles. Angle 1 is next to angle 2. That I can't call angle 1 angle A, because I'm not quite sure. If you tell me to look at angle A, are you asking me for this one, because A is the vertex there, or this one, because A is the vertex there, or are you talking about the whole way across? So you've got to be a little bit careful. The most commonly used notation is this 3-letter notation, and again with the vertex in the middle. So this says, what are 2 other names for angle 1? Vertex in the middle, vertex in the middle, angle out front, and then hug it. So go from J to M to K, or we could go from K to M to J. And those are 2 names for angle 1. Next up, what are 2 names for angle LMK? First of all, your eyes have to travel from L to M to K and know exactly, is it the one up here, the one down here, or is it the whole big one? So let's travel from L through the vertex. Sorry, I'm trying to go blue here. L through the vertex, M, because that's in the middle, out to K. You'll notice I made angle 2, and that's a viable name. Now, true or false, I can call it angle M. Great question for Ed Puzzle, right? True or false, it can be called angle M. False, because there's another one adjacent to it over here, and we don't know. Now, if this guy hadn't been here, then angle M, I know exactly what you're talking about. For example, when we start dealing with quadrilaterals, if I say KLM and I say, where is angle K? You know exactly, it's right here. I mean, there's only one angle there. There's nothing next to it. But now if I shoot this off and I say, who's angle K? We're not sure if it's this one, or again, the whole way across. So very important. What's another name to name that? Way to name that, we put the vertex in the middle and go the other way. So instead of going LKM, let's go KML. What's wrong with that green one? You should go, she forgot the symbol. Remember, without that there, I'm asking you for the plane, KML, the slice of the atmosphere, Earth, that those 3 letters are on. Now, this is something you know already, which is why I don't like to have things pre-typed out a whole lot. But in history of teaching this, most kids know the difference between acute, right, obtuse, and straight. Straight might be a new one for you. So pause and write these down if you need to. Again, you can use your notes on the test, but again, I'm not here to waste your time. So if you already knew all these, think of a cute little angle. It measures less than 90 degrees. An angle that measures exactly 90 degrees. Remember I said a degree is, there's 360 of them around a circle. So it makes sense, 90 over 360, right, is 1/4 of a circle. Makes this nice right angle in here. Or if I went another 4th and another 4th and another 4th, I'd go full 360. So there's that right angle, and we should know that that's what that little box in there means. Obtuse, a big obtuse angle, is more than 90 and less than 180. And then the straight angle looks kind of familiar, doesn't it? It kind of looks like a pair of opposite rays. It also looks like a line. Visually, they're all the same, so that's kind of cool. All right, next up, measuring. So when you measure the angles, remember, you're just traveling. This M in front means the measure of angle. So that's just telling you, instead of writing out, mathematicians love to have abbreviations for things, and we don't like to write words. So instead of saying, what is the measure of angle? It's just M angle. And you're supposed to know that that M means measure, and this symbol means the angle, and that you travel through the vertex. So we're just going to travel, like it says, from L. It's going to start at L, through the vertex K, boom, out to N. And so what I'm looking for is how many degrees this is. Now it's obviously more than 90, right? Because our 90 was like this and I'm like this. So it's a number bigger than 90. So when I go over here to see where this is shooting out, what we do is we look for 0, which is right. Let me go yellow on you here. Here's 0 right here on the inside, 10, 20, 30, 40, 50, 60, 70, 80, 90, and then I keep going to 100, and I gotta erase a little bit because I'm not quite sure. Looks like it goes right through 145, so it'd be 145. Probably the most common mistake is people reading this outside over here and either saying it's 45 or 35, but there's a couple ways to combat that. You can either say, well, I know it's obtuse, so it's got to be the larger number. Or remember, I'll always go through where the 0 is. The 0 is on the inside of what we call this ray, and the bigger numbers follow the inside around to there. So let's go take a look at the next one. And maybe you want to try it first. Again, it helps to pause and then you try, but let's travel from L to K to H. From L to K to H. Now again, I said follow the zero. Zero's on the outside for this one. So I'm going to follow the outside numbers, 10, 20, 35. And you can see that this is an acute angle, so that should also keep you from picking that other large number. But just kind of see where that zero is. Is it on the inside or the outside? All right, let's take a look at another one. JKL, let's go from J again to K is the vertex, out to L. Now this is going to require me to do a little subtraction here, or I can just count. Okay, so if I want to, if I realize that this is just 10 degrees, 20, 30, 40, 50, 5, it's probably the easiest way to do it is just to count. You could have gone the other way as well, but then be careful because this first little tick is only half of that distance, so 5. And then 10 more, 15, 25, 30, 35, 45. So you can just count across in those measures. Each little gap here is representing 10 degrees. What that means is this little piece right here, 10 degrees. Okay, so let's go try another one. How about, what do we have here? Let's go down here to JKN. So JKN, well, that's easy. I mean, you can see it makes that right angle, which is 90 degrees. How else could I have named that? I could have said find the measure of angle, and I could have gone N to K to J. Sorry, I didn't have real estate over there on the side of my screen. Oops, and that goes in the slot. You go do the last one and check it when you're done and see if you get it right. M to K to H. Pause the video and you go do it. Now that you're unpaused, let's go see how you did. So again, we're going to see where this starting ray goes through 0. It's on the outside. So I follow these outside numbers and I'm at 145. All right, now I can see that it's obtuse. Either way. So remember what we talked about, congruent segments. Here's that symbol again. This means that they have the same measure. So congruent segments have the same measure. To indicate those, a lot of times what they'll do is, like suppose I did a triangle like this, and I do a triangle like this, and I want you to know that on the red one, from A to B, is exactly the same measure as on this one from E to Q. What I would do is I would put a single dash on those. A single dash tells me those two are the same length because they both have single dashes. Or I'd say segment AB is congruent to segment EQ, or AB, the distance from, equals EQ. So there's ways to say that. Now, if I wanted to show that these two are the same, I would have to put 2 dashes because I want the same number of dashes means that those segments are congruent. So if this is 9, this is 9. Now, if I want this one to be different from this one, that means they're the same. If I go like that, it means they're different. Okay, it doesn't mean that they're one apart. It just means that they're different. Well, the angles work the same way. Congruent angles have the same measure. So if the measure of angle ABC is equal to, measures are numbers, right? If is equal to the measure of angle DEF, then we say angle ABC is congruent to angle DEF. That's what it means to be congruent. It means their measures are equal. Now, how do they show that on a diagram? If this was angle ABC, and again, if ever I'm going too fast, you just, vertex goes where the 2 rays meet, right? ABC. And if way over here on this side of the screen, I put angle DEF, remember vertex goes where the 2 rays meet. All right, if I were like, you know what, I would really like the Susie who's watching these notes to know that those have the same measure. They might say, well, why not just put the number in there? Well, sometimes, like if I put a 35 in one and a 35 in the other, you'd know they're congruent. But another thing they'll do is put the same number of arcs in them. So me going like this is telling you that angle B is congruent to angle E, also known as their measures are equal. Okay, so you should have a very good idea of what it means to be congruent. Now this looks familiar. Looks a lot like the one we had in the previous set of notes. It was called the segment addition postulate. If you remember, I used the three towns. I said, you know, Zimmerman to Elk River to Rogers, right down Highway 169. You could just add the two pieces to get all the way across. Works the exact same way with the angle addition postulate. And again, I talked in an earlier video about how that word postulate, it's just something that we take at face value because it's so obvious. There's really no way to prove it. It just is what it is. All right. So what the angle addition postulate says is that if I wanted to know the measure of this big angle, and I should, if we were doing this in class, I'd ask 3 of you, I'd say, name this angle. All right. And person, I don't know, Jill would say angle ADC. You say, yeah, angle ADC, that sounds good. And then maybe Billy says, or angle CDA. And I'd say, yep, that's good. And then student says angle D. I say, oh, you can't name that angle D. See if you know why. Okay, I'm gonna put that as a question. Why can't I name that angle D? All right, so that big green angle, I can get that by adding up the red one, it's measure, because they're adjacent, they're touching each other. And it's kind of like if you're turning a boat, like at sea, if you picture this being a boat kind of, and it's going this way and it turns 21 degrees and then turns 63 more degrees, it need not stop. It could have just turned 84 degrees, right? So that's what the angle addition postulate says. Let's put it in its notation. It says that the measure of angle A to D to B, the one in red, plus the measure of the angle B to D to C, okay? Let's go put that one in blue, equals the measure of angle A to D to C. Basically, the two pieces add up to the whole way. In terms of the numbers, we would say 21 degrees plus 63 degrees equals 84 degrees, the whole way. All right, so here it is with algebra like we did with the segment addition postulate. So it's just really important that you understand where the pieces go. So this is a picture off of, I believe, a worksheet. It says if R, Q, T, make sure you travel from R to Q to T. I always like to block it off and say, oh, it's that whole big turn of that angle. It's 155 degrees. Well, how could I get what the other two are? You don't set them equal because I didn't tell you. They look equal, but I'm not quite sure if those two are equal because nobody put these little arcs in here and nobody used a word that means to cut something in half. Anticipate what that word might be. I think it might be bisect. Right? But here's what I do know, that this term, which they said is 4x minus 20 degrees, plus this term, which equals 3x plus 14 degrees, is equal to the whole turn of the steering wheel. It's kind of like if you turn and then you turn, you could have just turned, right? Makes sense. So it could just equal this whole way across. Well, that's 155. And now we pass the ball to algebra, which means we go to both sides, we combine our like terms on the left. There are 7 x's. We have negative 20 plus 14 ones, so we're down 6 with those. Feel free to use a calculator. And that's 155. We go on the x attack by doing the opposite operation on both sides. Feel free to use a calculator. I get a 7x equals, and I get a 161. And then I have to divide 161 by 7. This goes in twice. 20. I don't have a calculator with me, but that's okay. So x is going to equal 23 when I divide both sides by 7. I am not done with the question. That's what's really deadly with these, is that it asked me not for x, but to find the measures of the angles. So I have to go back and plug those in. So you're going to go get a calculator and you're going to do that. And your question for your notes is going to be what those angles are, just to make sure you're staying engaged. You can use a calculator on your computer as well. So guided practice via worksheet 1.4. If you had to name this angle 3 ways, how would you name it? Okay, write that down. Again, just self-test yourself. Don't write down all these pictures. This does not have to go in your notes, but the first question would be name that 3 ways, pause and do it. The next question, I'd ask you, what's the measure of angle DFE and the measure of angle BFD? Okay, I want you to, this is a self-check. Okay, if we're doing this in class, I'd have them up and I'd walk around and check yours or have you check with a row partner or something, but unfortunately, we don't have that option here. Now, on this one down here, got a little problem because I'm missing some information. So how about, they don't look the same. So I was gonna put a single arc in them so you knew they were the same, but they don't look the same. What if I put that little box right there? Now would you be able to do it? Think about what that little box means. How many degrees is the whole way? And remember the two turns of your steering wheel have to equal the full turn. So set up and solve an equation that'll help you find, and let's find the measure of angle MKL. So we're gonna go back because I'm gonna ask you these 3 in the Ed puzzle. What are 3 names for this angle? Correct names. Find the measure of DFE and BFD. And lastly, find the measure of angle MKL. Okay, now I'm going to start you off with this one. The top part plus the bottom part has to equal the full turn. And the full turn is 90. So that's what you'll be solving. So you do that. Okay, pause the video and go solve those. And then last, if you look at this picture, there's a lot going on here. There's angles everywhere, but all these arcs are telling me who's congruent to who. So if I asked you, what angle is congruent to angle KJL? You go to the picture, you travel through that turn, through K, turn, out to L, and who has the same number of arcs? And the answer is this one right across from it. So you're going to say is congruent to, don't put equals, their measures are equal. The angles themselves are congruent. So the measure of angle KJL, or angle KJL is congruent to angle, and it's this one right here. So we have to figure out a way to name this guy, right? And I'm a little worried about, oh, that M must be for this point right here. So I'm okay. So I would go from I to J out to M, or from M to J out to I. But again, you can't call it angle J because there's more than one angle in there. All right. So we're going to say angle, let's just say MJI. Now, if I talked about them being equal, you'd say the measure of angle KJL is equal to the measure of angle MJI. It's kind of the same information. It's like me saying, if one of you is also 5'2", you're congruent to me because 5'2" equals 5'2". So do you see, there's a little bit of a difference there. So I'm going to challenge you on this one to name an angle because it has, that is congruent to angle QHG. Name an angle congruent to. You might say, well, how do I know? Remember, if it has the same number of arcs, it's congruent. So you're looking for an angle that has 2 arcs, and you need a correct way to name it. Okay, and that's it. You guys have a good one, and until next time, I shall be done. If I can figure out how to stop video. Stop share. Isn't this fun? I do it different every time, so it's like a